Today we talked about proportions and similar triangles, and it's pretty straightforward. It's just a few theorems that you would apply to these problems. So let's go through the theorems so far. You have the triangle proportionality theorem, which basically says that if a line is parallel to one side of a triangle, intersects the other two sides, then it divides the two sides proportionally. So in other words, if TU is parallel to QS, then that means that RT over TQ equals RU over US. So you could set up a nice little proportion, okay? So if RT was 9 and TQ was 4, and if SU was X, and then if RU was 12, then you could set a proportion with these numbers using this ratio right over here to help you figure out what the value of X is, just based off of the fact that these two lines are parallel to each other. Now the converse says basically the same thing, except it's just flipped. If you have a line that divides the two sides of a triangle proportionally, then you know that you have parallel lines and that this line is parallel to the third side. Okay? So again, say you were given all of these numbers, okay? Instead, you would actually set up a proportion between your sides to see if they equal each other. Because if they did, then you know the two lines would then indeed be parallel. Now these next two theorems do not have a name, but they're still useful because if it says if three parallel lines intersect two transversals, then they divide the transversals proportionally. So as you can see, R is parallel to S is parallel to T, and L and M represent your transversals. So since that's the case, then you know that UW over WY is equal to VX over XZ. And then the last one says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So in other words, if you have an angle bisector, then you know that AD over DB is equal to CA over CB. So then again, say AD was X, say BD was 3, say AC was 6, and say BC was 18. You could set up a proportion to find the value of X. Now please excuse me because I'm using the mouse on my laptop to write these numbers. Okay? So what I want you to do is I want you to let's go through these examples real quick. So find the value of the variable. This is the last theorem that you would apply. Okay? Because you have an angle bisector. So that means that X over 8 would equal whatever X minus 20 over 14 is. And you know this is X minus 20 because the whole length is 20 and this little segment is X. So that means that this segment right here would have to be 20 minus the value of X. Okay, so you would set a proportion, cross multiply, and solve. Now when you cross multiply, you have to be careful that you distribute the 8 to both the 20 and to the negative X. Okay, because if you don't, then you're going to end up with some weird numbers. And if you look at example number 2, this is with the whole 3 parallel lines cut by transversals. The parts are proportional. So you can set up a proportion. DE over EF is equal to AB over BC. So all you do is you will plug in your numbers, cross multiply, and solve. Okay? So now what I want you to do is I want you to pause this video and then try to complete each one of these. Alright? Now when you're ready to check your answers, then unpause the video and see how well you did. Okay, so hopefully you tried some of these problems. So we're going to go through the answers real quick. So first, it says that EF over FG is equal to BA over what? Well, if we're matching up the parts, then the answer here would be AG. And then you repeat this process all the way through, okay? CD over BA is equal to what value over EF, okay? If you look, the parts should match up. So the corresponding part that would match up with CD on the other side would be DE, all right? Let's keep going. For the next one, it says that EB over FA is equal to what over FG. Well, I'm looking for the same corresponding part that lines up with FG, and that would be EG. And you repeat this all the way through. I'm going to skip the explanation so much for the other ones and just let you know that for number 4, your answer should have been BG. For 5, it should have been CG. And for 6, it should have been DC. Now here we have to find the value of the variable so that the two lines are parallel. And if you recall from the converse of the triangle proportionality theorem, that if these lines are parallel only if these sides are proportional. So you would set up a proportion, x over 25 equals 8 over 20. Cross multiply, 20x equals 200, divided by 20, and x equals 10. And you do something very similar to all the others. You would set up a proportion, because I'm trying to prove that these are indeed parallel. So 8 over x minus 4 equals 6 over 12. Cross multiply. 12 times 8 is 96. And when I multiply 6 times x minus 4, I have to be careful and make sure that I distribute my 6 to my x and to my negative 4 for an answer that x equals 20. Similar thing, x minus 4 over 18 equals x minus 5 over 15. When I cross multiply, again, I have to be careful that I distribute the 15 to the x minus 4 and the 18 to the x minus 5. Distribute, add and subtract and divide where you need to, and x should equal 10. If at any point in time you need to pause this video, go ahead and do so. For the next ones, define AG. FC, ED, and AE, I have to set up a proportion. I know that using what I already have, to find number 10, I can set up AB over BC equals AG over GF. And then plug in. AB is 4, BC is 6, AG is what I'm looking for, and GF is 4, and cross multiply to get 2.7 if I round to the nearest 10. For number 11, I can set it up as AB over BG equals AC over CF. Plug in 4 over 3 equals 10 over X. Cross multiply and I'll get 7.5 as the value of FC. Okay, all I'm doing is using theorem 8.6 and sometimes theorem 8.4 to help me figure out what my proportions are. For number 12, you can say AB over BG equals AD over EF. Plug in your respective values and you find that the size you're looking for, ED, is equal to 11.25. And then the last one in number 13, I'm trying to find the value of AE. Well, AE is this length right here. I already know AD, and I already know BG, and so I can set it up as AE over GB equals AD over GB. So when I plug in, I'm looking for AE. I already know part of it, but I don't know the whole thing, so that's my X. GB is 3. AD, if I add up all the sides, is 15. And then GB is 3. Cross multiply, I get 3x equals 45. So then X would be 15.